Good morning Year 9 and welcome to today's maths lesson. Let's start off with a quick starter, shall we? Can you have a go at these 5 questions on your rough books or on your mini whiteboards for me? And then there's a GCSE question at the bottom to have a think about. So pause the video for about 5 minutes or so and have a go at as many of these questions as you can now, please. Okay, we'll run through some answers. So for the first one, to add those fractions, they've got different denominators. We need to put them over the same denominator and then add them together, and that would give you 5/6. The second one was a standard form question. You needed to move all those numbers 4 places on the place value table, and you'll know you're getting smaller because there is a negative in front of the 4. So that's going to give you 0.000671. Now writing 0.67 recurring as a fraction, that's using our algebra. We'll say that's equal to x, therefore 100x is 67.67, therefore 99x is going to be 67. And if you go through that process, you'll get 67 over 99. The next one was a comparing coefficients question. You needed to expand that bracket to give you 3x plus 6, and then the 3 corresponds with the a, so a is 3, and the 6 corresponds with the b, so the b is equal to 6. For the next one, I asked you to factorise that expression. That means put it into brackets. You know one of the brackets has got to be 2x. You know the two numbers are going to have to multiply to give you negative 21. And if you use negative 3 and 7, that will work for you. And then for my final question, I asked you a shot makes juice by mixing cranberry and orange in the ratio 1:3. If 1 litre of cranberry costs 60p and 1 litre of orange costs 40p, show that the cost of 20 litres of that combined juice is £9. And if you've done either of those methods, you'll get full marks for that question. Let's head into today's lesson. We're going to start with the diagnostic quiz. So A, B, C or D on your mini whiteboards or in your rough books, up to you. If you need any extra time as you go through, please feel free to pause the video and have a think. Question number 1, what is the area of this circle in terms of pi? Question number 2, what is the diameter of this circle? Remember, at any moment you can pause the video if you need any extra time. Question number 3, the area of this shape is given by which formula, A, B, C or D? Question number 4 for me, which of the following would correctly work out the arc length of this sector? And question number 5, the area of this sector is 10 centimetres squared. Which of the following will correctly work out the radius? Okay, let's look at some answers. If you need any extra time, you're welcome to pause the video and rewind. For question number 1, the area of the circle is given by pi r squared. We know the radius is 6, so r squared is 36. So the area is going to be 36 pi. For question number 2, I asked you for the diameter of this circle. Now the circumference is given by pi d. So if the circumference is 81 pi, you know the diameter must be equal to the 81. Your radius would be half of that. So your radius is going to be 40.5, however your diameter is 81. The next one, I look for the area of this one. So we know the area is pi r squared, but I've only got half a circle, so I need to divide that by 2. So the area is given by C. The question number 4, now we've got a sector, so we've got a fraction of that circle. And the fraction of that circle that I have is 110 out of 360. Because there's 360 degrees in that whole circle, and I've got 110 degrees of it. So therefore, if I want to work out the arc length, I know the circumference is given by pi d. I know my radius is 10, so my diameter is 20. So my circumference of my entire circle would be 20 pi. However, I've only got this fraction of the circle. So the calculation I'd need to do is that fraction, 110 over 360, times by pi times by 20, so the correct answer is C. And for the last one, I was told the area of this sector is 10. what could work out the radius? Okay, so we know the area of a circle is given by pi r squared. But we know the area is 10. And we've only got a fraction of it again. And that fraction is 21 out of 360. So 10 is equal to that fraction, 21 out of 360, times pi r squared. And if we rearrange that equation, that's going to give us b, r is equal to the square root of 10 over pi divided by 21 over 360. Let's head into today's lesson. On the board are two objects. I've got a brick and I've got a sponge. Which one will be heavier? Pause the video, have a little think. Which one do you reckon is heavier and why? Okay, hopefully we all know the brick is obviously going to be heavier. If I drop them both into water, the sponge would probably float, whereas the brick would sink. It would be heavier. And the reason being is these two objects have different densities. The density of the brick is much higher than the density of the sponge. So the amount of atoms packed into the brick is much greater than that of the sponge. Let's recap a formula triangle. So we've got A, B and C. I've used A, B and C. Obviously you could use speed, distance, time, etc, etc. We know this vertical line in the formula triangle represents a multiply, and this horizontal line represents a divide. So if we wanted to work out A, we could say A is equal to B divided by C. If we wanted to work out B, we'd say B is equal to A times C. We're going to use this to look at densities today. Now density tells us the amount of mass in a volume. It tells us how tightly matter is packed together. And common units you'll come across of density are things like grams per centimetre cubed or kilograms per metres cubed. And what you'll notice is density will tell you how different types of objects or how different liquids will sit. So here I have a variety of different liquids and solids, and if I mix them all together, they will actually form layers according to their relevant densities. So according to how tightly the matter is packed together. For example, at the bottom, I've got my most dense liquid and solid, which is honey and a bolt. On top of that will form a layer of corn syrup and popcorn kernel. On top of that, slightly less dense is your maple syrup and a dice. Milk is slightly less dense than that. Then I've got dish soap and a cherry tomato. Water, vegetable oil and beads will lie on a layer on top of that. Soda cap and rubbing oil will go on the top of that. And then on the top of all of that, I've got the lamp oil and the ping pong ball, the least dense materials. So density is irrespective of whether something is a solid or a liquid. Something can be more dense as a liquid than as a solid. So let's start off by looking at an object has a mass of 24 kilograms and a volume of 1 metre cubed. What is its density? Now the density this time is going to be 24 kilograms per metres cubed, because I've only got 1 metre cubed. So it's 24 kilograms per metre cubed. Now I've got an object which has a mass of 24 kilograms and a volume of 2 metres cubed. Can you predict what the density might be? Okay, here we've got the volume has got greater, however the mass has stayed the same. So to work out the density, i.e. kilograms per metres cubed, I'd need to divide it by 2. So the density of that object is going to be 12 kilograms per metres cubed. And what we've shown is density is equal to the mass divided by the volume. When I had 1 metres cubed, the density was 24 over 1. However, this time, when I had 2 meters cubed, the density was given by 24 divided by 2. Okay, now we've got a cuboid which has got dimensions 1 metre by 2 metres by 3 metres. It's got a mass of 24 kilograms. What is its density? Pause the video, have a little think. And here we go. This time the volume of this one is 1 times 2 times 3, which is 6. The density is given by mass over volume. Here our mass is 24 and our volume is 6. So the density is 4 kilograms per meters cubed. So let's put together our formula triangle for mass, volume and density. We know that density is equal to mass divided by volume. Therefore we also know mass is equal to density times volume, or we can work out volume is mass divided by density. In your dark blue books, can you write me the title density? You can write out this formula triangle for me. Underneath the title, mass, density and volume, then I'll go through an example and then there'll be one for you to do. So here's my example. I've been asked to work out the density of copper. Now the density is given by, if I cover that one up, mass divided by volume. So I'm looking at 150 divided by 17. And if I work that out on my calculator, that's going to give me 8.82 grams per centimetres cubed. Notice the use of units. Here we've got grams, here we've got centimetres cubed, so our density is going to be grams per centimetre cubed. Over to you guys in your dark blue books. Pause the video for a minute and work out this one for me. Okay, hopefully you've worked out the density is the mass divided by the volume, which in this case is going to give you 19.4 grams per centimetres cubed to 1 decimal place. Okay guys, in your rough books or on your mini whiteboards, up to you, pause the video for 5 minutes or so and have a go at working out the density of each of these materials. You are welcome to use a calculator. Off you go. And these are the answers I was looking for to 2 decimal places. Please check your work and see how you did. Okay, so far we've been looking at working out density. Now we're going to start looking at working out mass. Now if we look at our formula triangle, if we cover up mass, we know that mass is equal to density multiplied by volume. Here my density is 1.75 and my volume is 20. Now for this one I don't need a calculator because I know that 1.75 times 10 would give me 17.5, 17.5 times 2 will give me 35. And I've got 35 grams, looking at my units. Over to you guys in your dark blue books. Here's one for you. Do not use a calculator, please. Okay, hopefully you will have done mass is equal to density times volume. Therefore, you're looking at 17.5 grams. Over to you guys in your rough books or on your mini whiteboards. Please pause the video for 5 minutes or so, maybe 10 minutes, and have a go at these questions for me, please. Do not use a calculator, you do not need one. You can use your previous answer to help you with the next one. Off you go. And these are the answers I was looking for. Please check your work and see how you did. So we've looked at finding density, we've looked at finding mass. Guess what? We're going to look at finding volume. So in your dark blue books, I'll go through an example, then there'll be one for you to do. Here I've got volume is equal to my mass divided by my density. I've been told my mass is 20. I've been told my density is 1.75. Notice that because my units are both given in grams, I don't have to convert either of those units. And that's going to give me, using a calculator, 11.4 centimetres cubed to 1 decimal place. Over to you guys in your dark blue books. Pause the video for a minute. Here's one for you to do. And hopefully you'll have got the answer 5.71 centimetres cubed. Okay guys, switching to your rough books for me or your mini whiteboards. Please pause the video for 5 to 10 minutes and have a go at these questions. You're welcome to use a calculator. Off you go. And these are the answers I was looking for. Please check your work and see how you did. Okay guys, if you have any time remaining, please pause the video for as long as you need and have a go at as many of these questions as you can. Notice that for some of these, you are going to have to convert units. So for example, this one, I'm going to have to convert both of those into grams. 2 kilograms is going to be 2,000 grams. You're welcome to use a calculator. Pause the video now. And these are the answers I was looking for. Please check your work and see how you did. And here ends today's lesson. Please head over to Google Classroom and submit today's exit ticket. Thanks very much for listening, and I'll see you all tomorrow. Goodbye.